Welcome to the next installment of my video lecture series in economics. And in this particular video lecture, I'm going to be taking a look at something from my intermediate microeconomics course, which occurs in Chapter 9 and has to do with an algebraic solution to the issue of deadweight loss. So here's an example. You were given a demand function here. Quantity demanded is equal to 100 minus 1p, and quantity supplied is equal to 50 plus 1p. In equilibrium, we know that the quantity demanded is equal to the quantity supplied, so we set the demand and supply functions equal to one another, and we solve for p, and we get an equilibrium price of 25. We place that price back into either the supply and the demand functions, and we get that the equilibrium quantity is equal to 75. So it's useful to take a look at this in terms of an actual graph. Please note that this is not to scale. I was a little lazy here and I just used something I had pre-made, having a supply and demand curve on here. So just realize that these are not really to scale. So we have our equilibrium price of 25 and our equilibrium quantity of 75. We were told that we had a capacity constraint of 65. So what we want to know from that is what's going to be the price associated with that, with the supply curve at a quantity of 65. And we also want to know at that quantity what's the price on the demand curve for that. If we know those pieces of information, we can calculate the deadweight loss that was previously consumer surplus that was caused by this transportation constraint. And we could also calculate the deadweight loss that used to be producer surplus. So what we need to do is to calculate what the price on the supply curve is for a quantity of 65 and what's the price associated with a quantity demanded of 65. So all we would do is place that 65 back into the supply and demand equations to get what the prices for each that are associated with that quantity. So you can see here, we put the 65 in for quantity demanded and solve for that. We get a price of 35, and this is already up here. We put the 65, the capacity constraint, into the supply function and solve for it. We get a price of 15. So we can place those in, so we know that the price at a quantity of 65, at a quantity demanded of 65, the price is equal to 35, and at a quantity supplied of 65, the price is equal to 15. We can use that information to calculate each individual deadweight loss. So these are triangles, so it's 1/2 base times the height. So we have 1/2 35 minus 25, so that's the distance here, multiplied by 75 minus 65. That's the distance from here to there, and that gives us 50. We do the same exact thing for the deadweight loss from that used to be producer surplus. So we have 0.5 multiplied by 25 minus 15, giving us that distance. Again, please note that this is not to scale. And then we have 75 minus 65, giving that distance here, and that gives us 50. So we have a deadweight loss that used to be consumer surplus of 50. We have a deadweight loss of 50 that used to be producer surplus. We add both of those together, and that gives us a total deadweight loss of $100.